All right, so for number 9, well, I'm multiplying by square root of 18 over the square root of 18. You'll get negative 8 square root of 18 over the square root of 3, which is just 18. Now I had some questions. Guys, listen up. I have questions about where you go from that step. There's a couple of things you can do, but you need to decide on one of them. I see that 18, the square root of 18, that can be simplified. Create a factor tree. So 18 can be split up into what two numbers? 9 and 2. Then 9 can be split up into 3 and 3. I am looking for groups of 2 because my index is 2. So I am circling my 3's. 2 will be left over. So I'll have negative 8 times 3 root 2 over 18. From there, I can multiply negative 8 times 3. Negative 8 is negative 24. And then simplify it by doing negative 24 divided by 18, which is negative 4 thirds. So negative 4 root 2 over 3 should be your final answer. True, but not completely simplified. This one is better. What? I wrote the factor trees.
Where did the 4 over 3 come from?
Because 24 over 18 as a reduced fraction is 4 thirds. Any other questions? Okay, number 10. I can multiply square root of 2. That's going to get me 2 root 12 over, square root of 4 is 2. These cancel. I'm left with square root of 12, which can be simplified into 4 times 3. So my final answer is 2 root 3. So most of you got the square root of 12. You just had to take it one step further to simplify it as far as you can go. You wouldn't get full credit. Okay, so again, this is just a note. Multiplying by a form of 1 does not change the value of the equation. So all of these are equivalent. If you put them in your calculator and check to see that the decimals were the same, they will be the same. Simplified it. We didn't actually change the value of anything. So now in 11 and 12, we are going to do the same thing. They just look like fractions. So in number 11, I'm going to actually rewrite this so that they look like 2 fractions. And my first step then is going to be to simplify those radicals. You are creating factor trees for both of these so you can see how you can simplify them. So for 8, I'm going to write that up top here a little bit further. How can I split up 8? 2. And then 4 can be split up into 2 and 2. My index is 2. That's what I'm looking for, groups of 2. So I'll have negative 2 radical 2 because that 2. Now 45 I have to split up. So I'll write that up here. How do I split up 45? And then 9 can be split up into 3 and 3. So that's my group of 2. 5. So I'll have 3 radical 5. So that's all in your first step. You have to simplify the radicals as far as they go. Step 2, rationalize. Top of your paper, it says multiply the numerator and denominator by the radical in the denominator. So even though there's a 3 out in front, that's not going to matter. I'm only multiplying by the actual square root of 5. So my radical square root of 5, I'm multiplying the top by the square root of 5. Multiply the bottom by the square root of 5. Yes, good job. So negative 2 radical 10. What's going to happen in the denominator? Well, the radical, so square root of 5 times the square root of 5 is square root of 25. And what's the square root of 25? 5. So 3 times 5. So my final answer is negative 2 root 10 over 15. I can't simplify the square root of 10 any further. If I split it up into 5 and 2, I can't do anything with that. They're prime after that. So that's my final answer. So your final step is really just to simplify, which we did by multiplying 3 to 5. Same steps for number 12. So I need to split these up into two different fractions. So the square root of 200 x to the 6th over the square root of y. And then I'm going to simplify. Alright, so let's start off by simplifying the 200. So I'm going to create a factor tree for 200. What would you like to split that into? 102 would be my choice as well, because 100 can be split up into what two numbers? Good, 10 and 10. Since I have an index of 2, looking for groups of 2, this 2 will be left over. So far, I have 10. Leave some space in case we have to do something with that x. Radical 2. Now, like I've said a bunch of times in the past, if you're at that where you still have to write out 6 x's and then circle the groups of 2, please do so. But if you're able to take that next jump and not write those out, I would suggest trying to do that. So since my index is 2, how many times does 2 go into 6? 3 times. Then is there a remainder? No. So I'm putting 3 x's out here, so x cubed, but there aren't going to be any x's underneath the radical sign because I don't have any left over. In the denominator, I'm doing the same thing. So 2 goes into 7, how many times? 3 times, and then how many are left over? 1. So I have y cubed, and then I'm going to have 1 y left underneath the radical. So, like I said, you can draw out all of your x's. 6 x's, group them in groups of 2. 7 y's, group them in groups of 2. You'll have 1 left over. Or just do the division in your head. Whatever works best for you. Now, this next step is to rationalize. We don't have a number this time, we just have root of y that's underneath the radical that we have to get rid of. So I'm going to multiply the top and bottom by the square root of y, just like we did. Multiply them the same way. So we have 10x cubed, square root of 2y. And then in the denominator, we have y cubed times, what's the square root of y times the square root of y? Just plain y, because square root of y squared is y. Yes, it would be y. But simplifying, and that's how I'm going to simplify it. So 10x all over y to the 4th, and that's my final answer for this one. And then we're going to do practice. I might have you do practice from last class since I wasn't here through some of those questions, and then next class we'll do practice on this stuff. Last 2 questions. And last class, I know I didn't leave enough space for number 13, so keep that in mind. Okay, 13 compared to all the other ones we've done so far. index, and the index is what this time? 3. So I'm going to have to worry about that 3 when I go to rationalize. So my first step is going to be the same. I'm going to write them as the cubed root of 15 over the cubed root of 32. Before I start doing a whole bunch of factors, what can I do with the cubed root of 15? Will that split up? Will I be able to simplify that? No, because 15 is 5 times 3, and I'm not going to get a group of 3 out of that. Now, the cubed root of 32, that probably can be simplified. So up the top here, I'm going to make my factor tree. What two numbers multiply together to give me 32? 8 and 4 is one of them anyway. 8 can be split up into 4 and 2. Both can be split up into 2 and 2. Good. Now, my index is 3, so I'm looking for groups of 3. I have 3 2s, and then these are left over. So cubed root of 15 stays at the top in the numerator, but the cubed root of 32 becomes 2 cubed root of what? 4. Good job, because 2 times 2 is 4. Now here's where it gets a little bit, not more complicated really, it just changes. So since I have an index of 3, the denominator still, so my first step was still to simplify. Second step is still the rational. Different. And I want you to star this, it's important. So since I have an index of 3, in order to rationalize the denominator, I need to make it so that there are 3 groups. So for this one, we want to say I need 3 groups in the denominator when I have an index of 3. If I had a 4 as an index, if I have a 5 as an index, I'd be looking for a group of 5. Here's what that means for us. I'm going to rewrite this over here. Remember, when I rationalize, I only care about the radical. I don't care about the other number that's in front of it. And I need to multiply it by the cubed root of 4. So that there are 3 groups of that in the denominator. So here's 1, 2, 3 of these cubed root of 4s. I need to have 3 of them in order to get rid of the index of 3. So in the numerator, to multiply them together, I have the same index, so I can multiply all those things out. So what's 15 times 4 times 4? So cubed root of 240 goes in the numerator. In the denominator, I have 2. And since I have a group of these, you could write it as the cubed root of 64, but why would you do that if you could just write the number 4? So if you have 3 groups, it gets rid of the index. You're left with just the number that's underneath the radical sign. Now here's where it gets annoying again. We're going to have to create a factor for 240. How do you want to split up 240? Okay, 24 and 10. Yeah, it doesn't matter what you do. You'll end up... So 24, I can split up into... What do you want to split it up to? 6 and 4. 6 can be split up into 2 and 3. 4 can be split up into 2 and 2. Split up into 2 and 5. My index is 3. I'm looking for groups of 3. So I have a group right here of 2. And then there's... What? Define what your groups are coming from. So we have 2, 3, 2, 2, 2, and 5. I'm looking for groups of, as long as I have 1, 2, 3, 2s, it doesn't matter which circle, as long as you find, I don't care where they came from, it's as long as you're getting a group of 3. So I have 2 on the outside, but then I'll have 2 times 3 times 5, 30. So this is the number that's staying on the inside. So I have 2 cubed root of 30 all over 2 times 4, which is 8. Then we just reduce the fraction. So 2 over 8 is 1/4, so it's the cubed root of 30 over 4. And that's your final answer. The rationalizing part really isn't the hard part. It's usually having to simplify it after the fact. Number 14 is actually pretty straightforward and simple, so that's not too bad. $15 times 4 times 4 gave me 240. So I got the cubed root of 240, and then I had to split that up into my... So my last question for the day is number 14. We have the 4th root, so that means in the denominator, of 6y over x squared. So rewrite this as 2 separate things. So 4th root of 6y over the 4th root of x. Now usually our first step is to simplify. I can't do that. There's nothing I can simplify. So I'm just going to go ahead and multiply by the 4th root of x squared and rationalize the denominator. But like I said, I need a group of 4. So I'm multiplying by the 4th root of x squared, the 4th root of x squared, and I'm going to run out of a little bit of space here because of my factor tree, 4th root of x squared, bless you, so that I have 4 in the denominator. Since I have 4 of them, I can combine them. So I'll have in the denominator 4 of them. That cancels off with the 4 here, so all I'm left with is x squared in the denominator. I mean, if you really wanted to write the 4th root of x to the 8th, you could do that. And then in the numerator, I can just multiply everything that's here. So the 4th root of 6y, then x squared, x, and x squared. How many x's do we have? 6 of them, so it'll be x to the 6th. Final step here. Well, final 2 steps. I can simplify the 4th root of x to the 6th. Nothing else can be simplified. Because how many times does 4 go into 6? 2. So I have an x on the outside, 4th root of 6 squared over x squared. Use your exponent properties. I have 1 x on the top, 2 on the bottom, which means if I cancel them off, I'm going to have no x's in the numerator and 1 x in the denominator. So 4th root of 6y x squared over x is my final answer. Here's your final warning at the very bottom. So in this particular example, and last time when you had a warning on those notes, that's going to be on the test warning because it will probably be on a test. No, because so 1 on the top goes away, 2 on the bottom go down to 1. So in your warning, we have the cubed root of 4 times the cubed root of 4. That's the cubed root of 16. That's not going to simplify, and it certainly doesn't equal 4. What would have been better, so this is better, if you had the cubed root of 4 times the cubed root of 4 times the cubed root of 4. That'll give you the cubed root of 64, which is plain 4. So because they did not multiply the cubed root of 4 enough times, you ended up not being able to simplify it at all because of that. And that's why it works when we do the rationalizing the denominator. If we have a big index, we have to multiply it by that many that are in the index. Now, these questions that are at the bottom here are a review from 8.4. So if you want review from 8.4, I would suggest doing those problems. If you want a review for 8.5, I'm not sure if they're the same numbers, so you could try looking at 11 through 27 and 8.5 to practice, but that's up to you. And I will help you with whatever you do.